Hi, today we'll discuss interquartile range. Okay, we have seen in the previous class the range and coefficient of range. Now we'll see interquartile range. The range which takes into account only two extreme values, as we have discussed, is considered a rude, or we can say crude measure of dispersion. To overcome certain limitations of range, another method, known as interquartile range, has been developed. In simple words, interquartile range can be defined as the absolute difference between the upper and lower quartiles of a given frequency distribution. Okay, we will consider upper and lower quartiles of a given, as we know that Q3 is the upper quartile and Q1 is the lower quartile. Okay, and the difference between these two quartiles can be called as interquartile range. Okay, in other words, it includes only the middle 50% of the items in the distribution and ignores one quarter of the observations on either end of the distribution. Before Q1 you will leave, and after Q3 you will leave, and only you will consider the values that range between Q1 and Q3. That means only the middle 50% of the values you are considering for this purpose. It includes only the middle 50% of the items in the distribution, okay, and ignores the observation either end of the distribution. This the interquartile range is calculated by using a formula, that is IR, interquartile range, is equal to Q3 minus Q1, where Q3 is the upper quartile and Q1 is the lower quartile, right? And this is given. We will consider one example here for this. If you say uh, distribution Q3 and Q1, in a frequency distribution, Q3, Q1 are given 59 and 18 respectively. Its interquartile range will be 59 minus 18, you will get 41. Interquartile range is often used, okay, in the data pertaining to the socio-economic problems. It studies the absolute difference between the two quartiles, right? It studies the absolute difference between the two quartiles. Next, meaning of quartile deviation we'll discuss. To overcome the limitations of range, interquartile range and interquartile range we have discussed. Okay, another method of dispersion called quartile deviation is introduced. Meaning of quartile deviations we are going to discuss here. It has been developed from the interquartile range only. Quartile deviation, also known as semi interquartile range, we call it as semi interquartile range. Okay, it can be defined as the average absolute difference between the upper and lower quartiles of the frequency distribution. It studies the range of spread of various items either side of the median. Okay, but while studying the spread, it considers only 25% of the items on either side of the median, and it ignores nearly 50% of the items scattered on the extreme ends of the distribution. High degree of quartile deviation means low uniformity, and low degree of variation, hence less consistency in the formula of distribution and vice versa. Okay, quartile deviation is calculated with the help of a formula, that is QD is equal to Q3 minus Q1 by 2. Okay, where QD is equal to quartile deviation and Q3 is equal to upper quartile, Q1 is equal to lower quartile. Okay, quartile deviation is calculated as, okay, above absolute measure. This is useful in comparing the distribution expressed in homogeneous statistical units. But for comparing the distributions expressed in different statistical units, a relative measure is required. A relative measure of quartile deviation is required, that is known as a coefficient of quartile deviation is computed by using a formula stated in the PPT. Coefficient of quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. Okay, we'll consider one example. For this calculation of quartile deviation, we have a procedure, certain procedure for this. quartile deviation and the coefficient of quartile deviation. The steps to be followed here are arrange the values in ascending or descending order. First, what we need to do, arrange the given values in the ascending or descending order. Next, obtain the values of third quartile Q3. First, we need to get the Q3 values, and the next we need to get the values of first quartile, that is Q1. By using a formula, that is Q3 is equal to size of 3 into n plus 1 by 4th item. Okay, this is the formula for Q3. And for Q1, size of n plus 1 by 4th item, size of where Q3, 3 is the third item. Okay, Q3, that means third quartile, whereas Q1, here size of n plus 1 by 4th item only, where Q3, in order to know the third quartile, you are multiplying the same n plus 1 by 4th item. Where first item you are multiplying with 1, it won't make any difference. That's why n plus 1 by 4th item, you will get the Q1. Where n is the total number of observations in the given series. Okay. In case of discrete and continuous series, obtain the cumulative frequencies. In case of individual series, we don't have frequencies. Frequencies were not given. Okay, whereas in case of discrete and continuous series, you will have frequencies. Okay, for the location of upper and lower quartiles, you need to use the you need to cumulate the frequencies in case of discrete and continuous series. Further, in case of continuous series, okay, continuous and in case of continuous series, we have a difference in the formula in order to locate the quartile class. That is size of here before we use it for discrete and individual series n plus 1 by 4th item. Okay, for first quartile, 3n plus 1 by 4th item for the third quartile. But whereas in case of continuous series, you need to find Q3 size of 3n by 4th item. We don't need to add plus 1. Okay, whereas Q1 is size of first quartile n by 4th item. Okay, n by 4th item, right? This is another thing. Next, calculation of quartile deviation. Okay, as we know, it is a linear process, it will be continued. Since the values will be in continuous form, we need to apply a formula. Okay, that is locate the exact value of Q3. That is Q3. As we know that in a continuous series, class intervals will be given in a continuous form, and in order to locate the actual value of that quartile, okay, third quartile or first quartile, we have a formula, that is L plus 3n by 4 minus CF, cumulative frequency of the preceding class, okay, to the quartile class, by F into I. This is the formula which we use for in order to find out the median, where median can be called as Q2. Q2 is equal to the same figure, only you will get in spite of, that is n by 2 you will have, because second quartile, that can be called as second quartile, 2 into n by 4 is equal to 2 gets cancelled, then n by 2, that will become n by 2. Okay, there is a small difference. If you can remember one formula, you will remember all the formulas. Okay, there is a logic in all these formulas, right? Where Q3 is the upper quartile, that we know. Okay, and L is the lower limit of the upper quartile. Okay, and 3n by 4 size of the upper quartile, and CF, cumulative frequency of the class preceding the upper quartile class. Okay, class preceding the upper quartile class. F is frequency of the upper quartile class. I is class interval of lower quartile class, right? Third step is to obtain the quartile deviation, find out the difference between the upper quartile and lower quartile and divide it by 2. That is Q3 minus Q1 by 2. Okay, in order to get the quartile deviation. And fourth step is for obtaining the coefficient of quartile deviation. Okay, for obtaining the coefficient of quartile deviation, the difference between upper quartile and lower quartile is divided by the sum of upper quartile and lower quartiles. Okay, the difference between upper quartile and lower quartile is divided by the sum of the upper quartile and lower quartile. Then we call it as coefficient of quartile deviation. Next, calculation of quartile deviation and coefficient of quartile deviation for individual series. That will enable us to understand the concept in a better way. Okay, here data given, okay, pertaining to the passengers traveled in each bus of a traveling company. I was asked to find the quartile deviation and coefficient of quartile deviation. Passengers in each bus is given. Number of passengers, that is 43, 52, 37, 61, 41, 58, 72, 35, 65, 69, 75. Okay. And calculation was asked to calculate the QD and CQD. That means quartile deviation, coefficient of quartile deviation. Q3 is the size of 3n plus 1 by 4th item, whereas Q1 is the size of n plus 1 by 4th item. As we know that n is equal to 11, okay, there are number of observations given in the series. As it is an individual series, we will count the observations and we will come to know that n is equal to 11. Okay, Q3 is size of the item 3n plus 1 by 4. As we know the formula, we need to substitute the value of n, that is size of 3 into 11 plus 1 by 4, that is 12 plus 12 by 4. Okay, size of Q3 is 3 into 12 by 4th item. 12 by 4 you will get, if 4 3s are 12, that is 3 into 3. Size of Q3 is 3 into 3, third item. Okay, that is 3 into 3, ninth item will be the Q3. Size of ninth item in the distribution is 69. Okay, if you observe, if you keep them in ascending order, if you locate the ninth item will be the 69 in the given series, that is Q3. Okay, in the same manner we need to find the Q1. Size of n plus 1 by 4th item, that is n, we know the value of n is 11. 12 by 4, that is the size of 12 by 4th item will be the third item. Okay, 4 3 is a 3, hence third item. Size of third item, okay, if you see in the PPT given, okay, you will observe that third item will be the 41. Okay, now we know the Q3 and Q1, we need to substitute the same in the formula to find the quartile deviation, that is Q3 minus Q1 by 2. Q3 minus Q1 by 2, that is Q3 is 69 and Q1 is 41. Substituting the values in the formula, 69 minus 41 by 2, that is 69 minus 41, you will get 28. 28 by 2 is equal to 14. Okay, now we need to find the coefficient of quartile deviation. Okay, in order to find the coefficient of quartile deviation, we have a formula, that is Q3 minus Q1 by Q3 plus Q1, that is the difference between the quartile deviations by the sum of the quartile deviations, that is 69 minus 41 by 69 plus 41, 28 by 110, 0.255. Since the value of coefficient of quartile deviation is low, that is below the 50%, hence there is a greater uniformity in the distribution. If it is above the 50%, we conclude that near to 50%, we will say that neutral. Above the 50%, we conclude that less uniformity. Below the 50%, it is nearly below the near to 25%, hence more uniformity is found. We conclude that more uniformity found in the given distribution. Right. Here another example also given, data relating to number of defects per 100 trials in a manufacturing process, 2 machines. Okay, and he has asked to find out which machine is more uniform using the quartile deviation and coefficient of quartile deviation is asked. Okay, For the sake of convenience, we have discrete series taken there, but we will consider one individual series to compare the two machines. Okay, mission 1 is 2, 15, 12, 6, 16, 13, 7, 17, 139, 18, 14, 10, 19, 15. Mission 2 values are 12, 5, 15, 20, 12, 7, 16, 13, 8, 17, 14, 10, 19, 15, 11, 20. Okay, he was asked to calculate the quartile deviation and coefficient of quartile deviation. Now we will take two missions. We will arrange the given data in ascending order, and for Q3, for mission 1 we will first find out Q3 and Q1. As we know that the formula for find out the given Q3 and Q1 for the given data that is individual series is Q3 is equal size of 3n plus 1 by 4th item. If you do this, you know the value of the number of items, that is 15, given in the series both the missions, and 15 plus 1 by 4, 16 by 4. 16 by 4 is 4 4s are, hence 3 into 4, 12. Okay, the 12th item will be the 16, that is Q3 in case of first mission, and Q1 15 plus 1 by 4th item, that is 16 by 4, 4th item, hence 4th item is the 9th in the first mission. Okay, now we need to find the quartile deviation for the first mission, that is 16 minus 9 by 2, that is 7 by 2, that is 3.5 is the quartile deviation, whereas coefficient of quartile deviation is 16 minus 9 by 16 plus 9, that is 7 by 25, that is 0.25. Whereas if you solve the QD, quartile deviation, and coefficient of quartile deviation for the mission 2, the number of observations are same. Okay, hence 16 by 4 into 3 into 16 by 4, that is here the 12th item same, the Q3 is the 12th item, but 12th item if you locate in the given series, that is 16, whereas Q1 is the 4th item, you need to locate in the given series, that is 10. Now coefficient of quartile deviation is equal to Q3 minus Q1 by 2, that is 16 minus 10 by 2, that is 6 by 2. Okay, that is 3. Whereas coefficient of quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. Okay, that is 16 minus 10 by 6, 16 plus 10 is equal to 26. 6 by 26 is equal to 0.3. Since the values of quartile deviation is smaller for both the missions, both the distributions show the consistency. But relatively, mission 2 is considered to be more consistent because the mission is revealed by the coefficient of quartile deviation, both the missions. When you see the first mission is 0.2 value, coefficient of quartile deviation value of the first mission is, that is 0.28, whereas in the second mission that is 0.23. Hence second mission has less coefficient of quartile deviation and it is more consistent when compared with that of first. Of course both are consistent, but based on the coefficient of quartile deviation we will compare the given missions, right? Next, calculation of quartile deviation, coefficient of quartile deviation for discrete series. Okay, better understanding, we will consider one more problem on discrete series. Of course there is a small change in discrete and individual series where frequencies are not given in individual series, but frequencies are given in discrete series. Okay, data given is wages per day in rupees is given 10, 20, 30, 40, 50, 60, 70, 80, and number of persons are also given. The persons who are earning 10 rupees per day are 5, 20 rupees per day are 9, 30 rupees per day are 18, 40 rupees per day are 35, 50 rupees per day are 42, and 60 rupees per day are 32, 70 rupees per day are 15, 80 rupees per day are 10. Okay, calculations of quartile deviation and coefficient of quartile deviation. For this purpose, okay, wages per day in rupees are taken and number of persons. Now as frequency is given, we need to find out the cumulative frequencies. Cumulative frequencies can be get that, okay, by adding, okay, first person who are first people who are earning 10 rupees per day are taken first. 5, okay, 20 rupees per day earning people are 9. 5 plus 9, 14. Okay, in the same manner, 14 plus 18, 32, 32 plus 35, 67, 67 plus 42, 109. 109 plus 32, you will get 141. 141 plus 15, you will get 156. 156 plus 10, 166. Hence, n is equal to 166. In order to find out the Q3, size of 3 n plus 1 by 4th item that we know, okay, here n is equal to 166. 166 plus 1 by 4th. Okay, third Q3 we want to find out 3 into 166 plus 1 by 4. That is 3 into 167 by 4. 3 into 41.75. Okay, 167 by 4 you will get 41.75. Hence 3 into 41.75 fifth item. The total will be the sum will be 125.2 fifth item. 125.2 fifth item we need to locate in the cumulative frequency. That will lies in 141. Okay, the corresponding number 60, that means wage per day will be the Q3. Now we need to find out the Q1. Size of 160 is, that is means n plus 1 by 4th item. We know that 166 is the n value. 161 plus 166 plus 1, 167. Okay, 167 by 4 we will get 41.75th item. 41.75th item, if you locate in the cumulative frequency, that will exist in the okay, that will lie in the 67 of the frequency, and that is the corresponding value will be the 40. Okay, hence QD is equal to Q3 minus Q1 by 2. That is here Q3 is equal to 60 and Q1 is equal to 40. Now substituting the values, QD is equal to 60 minus 40 by 2. That is 20 by 2 is equal to 10. Where coefficient of a quartile deviation Q3 minus Q1 by Q3 plus Q1. That is 60 minus 40 by 60 plus 40. 20 by 100, 0.2. Since the coefficient of quartile deviation is low, the distribution is more consistent and more uniform. With this, okay, with the example will come to know. When we consider another what we call as another example pertaining to two different brands, okay, we will compare. That will enable us to get more comprehensive understanding and concept, right? Two brand of electric bulbs are tested for their lighting capacity, and the following results are obtained. They are given here. I am not showing on the PPT because of paucity of time. Of course, I will explain the same while right. With the help of quartile deviation and its coefficient, find out which brand of electric bulbs is more constant. He has asked. Lighting hours are given for brand A, okay, number of bulbs, and brand B. Okay, lighting hours for both are same. He has given 50, 100, 150, 200, 250 and 300 are the lighting hours. And in the okay, lighting hours life, brand A and brand B bulbs are given respectively. 50 lighting hours brand A is 32, brand B is 19. 100 okay, lighting hours brand A is 28, brand B is 34. For 150 lighting hours brand A is 30 bulbs, brand B is 57 bulbs. For 200 lighting hours brand A 36 bulbs and brand B 66 bulbs. 250 lighting hours the brand A bulbs are 34 and number of bulbs 57, brand B are 57. Whereas 300 lighting hours the brand A bulbs are 40 and the brand B bulbs are 53. Okay, from this you need to find the number of bulbs is considered as frequency f, lighting hours are considered as x. We need to find out cumulative frequencies for both the brands given in the brand A and brand B. If you take cumulative frequencies, calculate cumulative frequencies for brand A, that is 32 plus 2860 plus 3090 plus 36 126 plus 34 160 plus 40 200. This will be the pattern of cumulative frequency for brand A. Whereas brand B, um, cumulative frequencies are 19 plus 50, 19 plus 34, 53, 53 plus 57, 110, 110 plus 66, 176, 176 plus 57, 233, 233 plus 53, you will get 286. That means n is equal to 200 in case of brand A, n is equal to 86 in case of brand B. Now, in order to find out the Q3 for the grievance series, okay, that is Q3 for A, brand A is, okay, first we will calculate as 3 into n plus 1 by 4, we know the formula. N is equal to 200 for brand A. Okay, size of Q3 is size of 3 into 200 plus 1 by 4, that is 3 into 201 by 4. 201 by 4 is equal to, that is 50.25. 3 into 50.25 is 150.75th item. 150.75th item lies in the 160th cumulative frequency. Hence, the corresponding number, that is 34, will be the Q3 for brand A. Whereas, okay, the frequency is 34 and lighting hours is 250 for the Q3. And if you find Q1, that is okay, 200 plus 1 by 4th item, because brand A cumulative n is equal to 200. 201 by 4 is 50.25th item. 50.25th item lies in which of the cumulative frequency? 60. Hence, the corresponding number, that is 100. Q1, the number of lighting hours is 100, that is Q1. Now, QD, we find QD for brand A. Q3 minus Q2 is by 2. Q3 is 250, Q1 is 100. Okay, 250 minus 100 by 2, that is 150 by 2 is equal to 75. Coefficient of quartile deviation for this same is 250 minus 100 by 250 plus 100. 150 by 350, that is equal to 0.429. For brand B, if we consider n is equal to 86, we know that. Okay, Q3 size of the third item, that is 3 into 286 plus 1 by 4. 287 by 1 by 4 into 3, that is 3 into 71.75, that is 287 by 4 value is 71.75, okay, which into 3, that is 215.25th item. Okay, if you locate the same in the cumulative frequency of brand B, you will get 233, that is 233 will be located, you will have 215 will be in the 233. 233 corresponding value is 250. 250 bulb hours. Q3 will be the same for this also, brand B also. And now we need to find out Q1. Q1 is 286 plus 1 by 4. That is size of the n plus 1 by 4th item. That is 287 by 4. 287 by 4 is nothing but 71.75th item. 71.75th item will be located, okay, in the cumulative frequency, that is 110. The corresponding value of 110 is 150. But earlier for brand A we got Q1 is 100, whereas we got Q1 is 150. Now quartile deviation we need to find out for the same, that is Q3 minus Q1 by 2. We know that for brand B, Q3 is 250 as same in brand A, but Q1 is differs. Whereas for brand A is Q1 is 100, whereas for brand B Q1 is 150. Substituting the values, you will get QD. That is 250 minus 150 by 200, 2. That is 250 minus 150, 100. 100 by 2 is equal to 50. Whereas coefficient of quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. That is 250 minus 150 by 250 plus 150. That is 100 by 400, 0.25. By observing the coefficient of quartile deviation of both the brands, brand A and brand B, since the coefficient of quartile deviation of brand B bulbs is low, it has more consistent lighting and performance. See, we will conclude from the observations. Okay, right. Next, calculation of QD and coefficient of quartile deviation. QD means quartile deviation and coefficient of quartile deviation for continuous series. We'll consider. Okay, by understand in a better way by looking at the PPT. Okay, he has given marks between the range, okay, 0 15 15 30 30 45 45 60 60 75 75 90. Number of students are 8 5 13 15 5 4. Okay, now we will solve the problem. Mm, in order to find Q3, the size of Q3, okay, he has given only marks and number of students. We need to find the cumulative frequencies. Okay, by seeing at the formula, you will have, okay, I wrote the mistakenly both the cumulative frequencies, but here cumulative frequency is right, but the number of students is not right. Number of students are 8 5 13 15 5 4. These can be made a correction in the PPT, right? If you find Q3, size of 3 into n by 4th item, okay, n by 4th item, and Q1 is size of n by 4th item. Okay, we are not considering, whereas in individual series and discrete series we have considered. Okay, in order to locate the Q3, we have n plus 1 by 3 into n plus 1 by 4th item, but whereas in continuous series Q3 is size of the 3n by 4th item, for Q1 size of n by 4th item. N is the number of frequencies that we came to know from the uh, given series, that is n is equal to 50. Q3 is the size of 3 into 50 by 4, that is 3 into 12.5, that is 37.5th item. 37.5th item will be in which frequency, cumulative frequency, that lies in the cumulative frequency of 41, hence the corresponding class. Okay, 45 60 will be the Q3 class. Okay, now we need to require locate the exact value of Q3. For that we have a formula that was used earlier. That is Q3 is equal to L plus 3n by 4 minus Cf by F into I, where L is equal to 45, we know. 3 into n by 4, 37.5. Okay, 37.5. 37.5 and Cf is equal to 26. Cumulative frequency of the preceding class, we call it as. Okay, uh, preceding class to the quartile class. That is, F is given, F is the frequency of the quartile class, that is 15. And I is the class interval of the quartile class, that is also 15. Okay, substituting these values in the given formula, that is Q3 is equal to 45 plus 37.5 minus 26, okay, by 15 into 15. Okay, that is 45 plus 37 minus 37.5 minus 26, that is 11.5 by 15 into 15. 45 plus 11.5 by 15 is equal to 11.5 into 15 we have, hence 15 gets cancelled. 45 plus 11.5 will be the remainder, which is equal to, if you add 45 to the 11.5, you will get 56.5. You will come to know when you observe the PPT. Next, Q1 is equal to size of n by 4th item. Size of n by 4th item, n value we know that 50 from the cumulative frequency, that is 50 by 4th item, 12.5th item. Size of the 12.5th item will be, okay, located in frequency of the cumulative frequency of 13. The corresponding class, okay, to the cumulative frequency 13 is 1530. Okay, 1530 will be the Q1 class. Okay, to find the exact value of Q1, we need to apply the same in the substitute in the formula. Okay, that is Q1 is equal to L plus n by 4 minus Cf by F into I. We know this formula. Okay, here L is equal to 15, we know that. N by 4 is equal to 12.5, we know that. Cf is equal to cumulative frequency of the preceding class of the Q1 is, that is 8, and F is the frequency of the Q1 class, that is 5. I is the class interval of the quartile class, that is Q1 class is 15. Substituting these values, we will get Q1 is equal to 15 plus 12.5 minus 8 by 5 into 15. where 12.5 minus 8 is equal to 4.5. Hence 15 plus 4.5 by 5 into 15, which is equal to 15 plus 13.5. Okay, 15 5 and 5 3s are, that means 3 into 4.5 is equal to 13.5. 15 plus 13.5 is equal to 28.5. Now we need to calculate quartile deviation, that is Q3 minus Q1 by 2. Here Q3 is equal to 56.5 and Q1 is equal to 28.5. Okay, substituting the values in the formula, QD is equal to 56.5 minus 28.5 by 2. 28 by 2 is equal to 14. Coefficient of quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. This is the formula given and we know that. Now we need to substitute the same in the formula coefficient of quartile deviation. That is Q3 we know that 56.5, Q1 28.5. Hence 56.5 minus 28.5 by 56.5 plus 28.5, 28 by 85, which is equal to 0.329. Since quartile deviation of marks of, okay, 14 and the coefficient of quartile deviation of marks is 0.3 or small, the distribution has a consistency. Okay, by looking at this we will have consistency. Okay, from the following data we have one more example here. From observing this also we can okay, by calculating here what he has given uh, as class intervals in inclusive method and adjustment of class intervals are necessary. Here 18, 21, 22, 25, 26, 35, 36, 45, 46, 45 is given. Okay, frequency we need to find out cumulative, everything is same, but when frequencies are given, class intervals are given in inclusive method, we need to adjust them. Okay, uh, according to the given says, that is here 1821 is given. From the lower limit we need to subtract 0.5 and from the upper limit we need to add 0.5. In such a manner we will convert the given in data, okay, which is given in the uh, inclusive method can be converted into exclusive method. Then the formula will be 7.5, 17.5, 21.5, 21.5, 25.5. Same procedure will be the same. When it is given in the inclusive method, we need to convert the same into exclusive method and need to find out the formula. Okay. Next, another problem is given, that is value less than is given. Okay, less than 10, less than 20, less than 30, less than 40, less than 50, less than 60, less than 70, less than 80. Now we need to convert, okay, less than into adjustable class interval. Okay, we should have a definite uh, class intervals. Okay, once 0, 10, 10, 20, 20, 30, 30, 40, 40, 50, okay, and 70, 80 will be the last class. The frequencies, there is no change at all in the given frequencies, but we need to convert the frequencies, because as the values are given in the less than form, they will be in the cumulative frequencies. Now the given cumulative frequency form can be converted into frequencies. The last number will be the n is equal to 120. Okay, for cumulative frequency less than 10 we have 68, 0 10 we will have same, less than 20 we have 143. From 143 we need to subtract 68, we will get 75. Okay, between 10 20 class. If we want to 20 30 class frequency, if you want to know the okay, less than frequency is 200, 200 minus 153 will get 57. In the same manner, uh, less than 50 you have less than 40 you have 279. Okay, 279 minus 200 you will get 79. Less than 50 you have 311, 311 minus 279 you will get 32. Less than 60 you have 356, 356 minus 311 you have 45. Less than 389, that means 70, you have 389 frequency, 389 minus 356 you have 33. Less than 80 you have 420, 420 minus 389 you will get 31. In the same manner you will form the frequencies, and the procedure is same as you know that. Okay, in order to find out the Q3, that is 3n by 4th item, and to locate the exact value of Q3, we have a formula. Q3 is equal to L plus 3n by 4 by minus Cf by F into I. The formula and application of the formulas is same, and okay, by solving those you can get the value of the Qd and Q1, and by applying the quartile deviation formula, that is Q3 minus Q1 by 2, you will get the quartile deviation, and in order to get the coefficient of quartile deviation you need to apply the formula Q3 minus Q1 by Q3 plus Q1. Okay, with that we can infer the gain results. We can interpret the results which we got, whether the given series is uniform or consistent, right? And next we have merits of quartile deviation. Merits, what are the advantages, or we can say that merits of quartile deviation. Quartile deviation is a simple to calculate and easy to understand, that we have seen, okay, by going through this class, right? It is also easy to compute even in case of distribution with open-end class. Okay, in case of open-end class also we have converted the same into according to our requirement, and we have solved the problem, right? Since 50% of the observations in the distribution are taken into account, it can be treated as a better measure of dispersion, okay, than range. Okay, with this we conclude that, okay, by observing the range and quartile deviation, we can say that it is a better measure than the range. Okay, as observed by Giffen, the quartile deviation is useful location based on measure of dispersion, because even though there is some departure from symmetry, okay, approximately half of the observations will be included in the range of plus and minus 1 quartile deviation around the median. Okay, whereas in case of range only we will consider the two extreme values, but here we are considering half of the observations. Okay, hence it is a good measure about we can say that when compared with that of range. This half of the observation is the central half of, and therefore exclude the extreme values. Okay, uh, definitely it's a advantage over the range. When we compare the another measure of dispersion range, it is absolutely an advantage using the quartile deviation and coefficient of quartile deviation, right? Next we'll discuss limitations of QD. Of course there are many advantages, in spite of those advantages we have some limitations in finding these quartile deviation. It does not depend upon every value of the distribution. If we consider every value of the distribution, certainly that will make, okay, valid inferences, but it is not so in case of quartile deviation, so it cannot be considered as a satisfactory measure of dispersion. Okay, next, the values of quartile deviation is affected by sampling fluctuations. The values of the quartile deviation is affected by sampling fluctuations. As we know that 50% of the values of a given series is used. Okay, the quartile deviation is affected by the sampling fluctuations. If you alter the samples, that will affect the quartile deviation. Okay, this is also a limitation that we come across here. Quartile deviation cannot be subjected to further statistical treatment. Quartile deviations cannot be subjected for further statistical deviation, okay, treatment. We can't use quartile deviation for further statistical, okay, treatment, further for statistical calculations. We can't do further calculation based on this quartile deviation. That is also a limitation for the quartile deviations, right? And it does not reveal the extreme extent of variability of the values. We can say the variability, but we can't define what extent the variability exists in the given series. Okay, that cannot be known with the quartile deviation. That is also a limitation. If you know the exact deviation, that is better for you, but it is not so happening in this case, right? And that is also a limitation that we have considered here. Due to these limitations, okay, what we have discussed so far, Due to these limitations, quartile deviation is not commonly used as a measure of dispersion. We are not using it as a measure of dispersion. To overcome some of the limitations of quartile deviation, certain other measures of dispersions, okay, like mean deviation, standard deviation, have been developed. Okay, we will discuss those concepts, that mean deviation and standard deviation, in subsequent chapters, right? With this, we have concluded the class, and thank you for listening. Right, thank you.